Hello everyone, I hope you are doing well. In this video, we are going to solve problem 209 minimum size subarray sum in the Leetcode series. So let's see what's the problem wants us to solve. So based on the description of the problem give us the array. That array contains the list of integers and the target number. And we need to find the minimum length of the numbers that the sum of the numbers is equal or greater than the target. So assume that we have these numbers as an input. Let's analyze it and see how we are going to solve the problem. So I'm writing the numbers here: 2, 3, 1, 2, 4, 3. This is the array that the problem gave us. And this is the target, number 7. So we need to find the numbers in the minimum length that the sum of the numbers is equal to the target or greater than to the target. For example, think I'm starting from 2. I'm just using 2, then adding 3, then adding 1. We have 5, then 6, and if I added 2, it equal to 8. It's greater than the target, but I use 1, 2, 3, 4 entities. I need to find the minimum size of subarray. So let's try with 3. 3 plus 1 plus 2 plus 4. Then this one get 5, 6, and this one is 10. This one is greater or equal than the target, but the length of this array is 4. Let's move one more. 1, 2, and then 4. 1 plus 2 plus 4 equal to 7. This one is equal and greater than 7. But this one I think is the better choice because the length of this subarray is 3. Previous one was 4. Let's try to use this one. 4 plus 3. This one get to 7. So we achieve our target and the 7 is equal or greater than the target. But the length is minimum because the length is 2. So let's see how we want to solve this problem when we are going to code this problem. So this is a type of the problems that we need to handle the window. As you see, I've started from 2, then I moved to 3, then I moved to 1. So, and each time we have a window that I'm going to move the window, or maybe sometimes increase the window, sometimes decrease the window. And if I want to work with the windows, I always need 2 pointers. So all the problems that are going to solve with the window solution, we need to have a 2 pointer. 1 pointer point to the start of the window, 1 pointer point to the end of the window. Okay, think that I have a 2 pointer. The first pointer that I named S point to the first item, the pointer that I have, and I name it E, point to the S point to the first item, the E point to the last item. So think that the pointer is here. And I'm just using S equals 0, E equals 0. Then I need to have a sum to know, okay, the numbers that I have in the window get to which number. For example, right now, both of them point to the 2, so the sum is equal to. So the 2 is less than target, so I need to increase the window size. So I can move A to this item. So I move N to the position 1, and I get sum to the 5. Okay, 5 is less than target. So I need to increase the window. I'm going to move the end pointer to here. So when I'm moving this, I'm adding 1 to 5, so the sum get to 6. So I need to increase the window again. I move the end to this here. So and move to position 3, and then we have 5, 6, 7, 8. Good. So the sum right now is equal or greater than a target. And the window size that I have here is 1, 2, 3, 4. So I can have something like a result or win size, and window size right now is equal to 4. This is the minimum that we find right now. So after that, what should I do? Do I need to increase the window? No, I need to decrease the window. But how? I need to move the start one step ahead. So I move the start to this position. If I move a start here, I need to calculate the sum. So the sum is 3, 1, 2. So the sum get to 6. 6 is less than 7. So I need to move the end again. So I move the E to this position. End. So let's calculate the sum. 5, 6, 10. Sum gets to the 10. And how many item I have in this window? 1, 2, 3, 4. The same as size as the minimum size. So I need to move the start again. I move the start to here. So start get to 2. And I'm just calculating the sum again. 1 plus 4 equal 5 plus 2 equal 7. How many items do I have in the window? I have 3 items, so I can decrease the window size because I'm looking for the minimum 1 to 3. Then I need to move the start one more time. I move this start to here. 5. 0, 1, 2, 3. Oh, I made a mistake, sorry. 0, 1, 2, 3. I move it to the 3 and end is moved point to 4. 0, 1, 2, 3, 4. Yes. So right now, what's the sum? The sum is equal 6. It's less than 0. So I need to move the end one step to the right. So E point and point to the 5, and the sum will get to 6, 6 plus 3, sum get to the 9. 9 is equal and greater than set target, yes, and the minimum size is still 3. So same as the things that I did previously, I need to move start one step ahead. So I move this one to 4 and calculate the sum. 4 plus 3 equal to 7. Oh, great. So, and I have 2 items here, and the 2 is less than 3. So I calculate the minimum size again and set the minimum size to 2 and return the 2. And this is the result of the problem. So let's implement the same things in the code. Okay. Let's do the same here. So this is the method that you will see in the Leetcode when you start implementing this problem in Java. You will see different name or a structure if you use different languages, but the structure of the implementation will be the same. It's not related to the which language that you are going to implement. Subarray length. And as you see, solution give us the target that we need to find the minimum window, that then the sum of the minimum window will be equal or greater than the target. and we will receive the list of integers. So first thing first, you saw that I defined some pointers because I told you this is a problem that we are going to solve it with the window. And always for window, we need two pointers. One of them point to the start of the window, one of them point to the end of the window. So I need to define two pointers. And initially, these two pointers point to the first item in the array. Then I need to define variable to keep the sum of the items that we have in the window. And because currently we are setting the start and end of the window to the first item of the first item in the array, sorry, the sum will be equal to the value of the first item in the array. And then I need to have a variable to keep the minimum window size. I name it minimum window size, and initially this one is 0 because if we will not find any window that some of the items in that window be equal or greater than the target, we should return 0 at the end. Then we need to have a while, and we need to always make sure that the start of the window will not pass the end of the window, as long as the start pointer is less than equal the end pointer. I'm going to run this loop. Why I put this criteria here? As I show you here, for example, think about this one again. Think that this is the start pointer and this is the end pointer. A start pointer should never pass the end pointer. If a start pointer passed the end pointer, it means that we couldn't find any window that match the criteria, and it will not be equal or greater than the target that we have. And that's the reason that I put this criteria here. So after this, I need to check something. If, for example, the start item that right now they start pointing to that one is equal or greater than a target, we don't need to check the other things. We can return those results. If the numbers that the integer number that the start pointer point to it be equal to the target, equal or greater than the target. So that's something that we are looking for. So immediately we can return 1. For example, think that the target is 6 and the array that we are processing be something like this. And the start pointer point to the 7. 7 is equal or greater than the target that it was 6. So we know that the minimum array will be the size of 1, and we can immediately return 1. In the other cases, we need to check if sum greater or equal than a target. We need to check if result equals 0 because we have started. Okay, sorry, I name it here as a minimum window. If minimum window equals 0 or end minus start less than minimum window less than minimum window, we are going to set the minimum window equal end minus start plus 1. This is for this one. In the other case, if we find, okay, it's greater than equal target, but minimum window that we find by subtracting n to the start is greater than the minimum window that we previously found. As I show you, we need to move start pointer one step to the right. So I need to just calculate the sum again by reducing the value of the numbers that I have currently in the start. Then move the start one step to the right. Why I'm reducing the value of the sum for the start first? For example, think that we have this array 2, 3, 1, 2, 4, 3. A start point to here, end point to here, and the sum is 1 plus 2 plus 4. The sum is 7. I want to move the start one step to the right. So I want to move the start from this position to this position. So I need to remove 1 from the sum that I was calculated. So that's something that I did here. So I first remove the 1 from the sum that I calculated, then I move the start 1 step to the right. Else, if the sum was not equal or greater than the target, and the sum that we found is less than a target, what we should do here? So first thing that we need to do is we need to, as I show you, we need to move the end pointer one step to the right. But we need to always make sure that the end pointer will not pass the end of the array length. So I need to have some check here and make sure that the end pointer is always less than the length of the array. And if it's less than the length of the array, I can increase it. And just as I show you, I can increase the sum by add that numbers to the sum. And what's happened if the array that end pointer, point to the last item of the array? We should not move the end pointer. We should move the start pointer. And I need to do the same thing that I did here to move the start array one step to the right. So this is the solution. Okay, I'm just trying to, and then we are going to return minimum window, and that's it. This is our solution. And as you see, this solution is really easy. We just create a window we just move the start and end of the window to find the minimum length of the window. Then the sum of the numbers that is that are in the window is less than is greater or equal than the target that we have. Okay, as you see, we discussed the solution, how to solve this problem. But one thing remains, and it's about the time complexity and space complexity of this problem. As you see, we defined two pointers, and we have started from the first element to the last element. We didn't have any inner loop. So because this problem was solved with the windows, and we have a pointer to point to the point to the start of the window, and we had a pointer that point to the end of the window, this problem time complexity is On, because we visit each element of array one time through the window. And by just increasing the window or decreasing the window, we just move the window from left to the right. What about the space complexity? Did we define any additional array? No, we didn't define any additional array. We used the same array that we received. We just defined two or three variables to keep the pointer to the start and end of the window, and keep this value of the sum and minimum value that defined for the sub array. So we didn't define any additional array. So the space complexity for this one is 1. So we solved the problem with the time complexity of On and a space complexity of O1. So I hope you like the way that I solved this problem. You can always find this solution in the GitHub repository that I put in the description. See you in the next video.